Yellowstone National Park is one of the most popular parks in the United States, known for its geysers, hot springs, and most famously, its bison. But it's also home to something even more amazing, at least if you ask me, volcanoes. The park sits atop the largest supervolcano in the world. And while we don't expect it to blow anytime soon, scientists recently discovered that things have been changing underneath the surface. So, what's really going on here? Let's dig into the science behind this shifting map. Let's start with some fun facts about Yellowstone, because this place is straight up wild. It covers an area of over 2,000 square miles, which is larger than the entire country of Ireland. That size includes thousands of geothermal features or places where hot water and steam escape from the ground. This includes 450 geysers, including the famous Old Faithful, hundreds of hot springs, and a bunch of mud pots. All these features are powered by heat from the magma chamber below the surface. Magma is molten rock found beneath the Earth's crust, and the chamber is the underground storage area for all that molten goodness. But wait, there's more. Yellowstone's magma chamber is also the source of the park's cute little earthquakes. Yep, you heard me right, earthquakes. The Yellowstone Supervolcano has been rumbling beneath the surface for millions of years. And every now and then it shakes things up literally. In fact, it's the second most seismically active place in the US after California. Between 1850 and 2018, there were almost 20,000 earthquakes recorded around Yellowstone. Most of these quakes are pretty small, but big ones happen too. In 1985, a magnitude 7.3 earthquake struck near the town of West Yellowstone, Montana. It was felt as far away as Idaho and Utah and caused over $10 million in damages. So yes, it's clear that Yellowstone is a bit of a handful. But why does any of this matter? Why should you care about the rumblings of an ancient volcano half a continent away? Well, because when it erupts, it could be pretty bad. The thing is, supervolcanoes aren't like regular volcanoes. When they erupt, they send out massive amounts of ash and lava. We're talking hundreds of cubic miles of the stuff. For perspective, Mount St. Helens, one of the most famous volcanoes in the US, sent out about 3 cubic miles of material during its 1980 eruption. Now imagine that number times 1,000, and you'll be closer to the scale of a super eruption. And this doesn't even count the pyroclastic flow or hot gas and solid pieces of rock that rush down the volcano's slopes during an eruption. Now, we're not saying that Yellowstone is overdue for a blast. In fact, recent research suggests that the next eruption might still be a few thousand years away. But the thing is, no one can say for sure. There's also a chance that the next eruption will be even more dangerous than we think because of something called a liqui-flow. A liqui-flow happens when superheated water vapor gets released during an eruption. Think of it like opening the lid on a pot of boiling water. The steam shoots up and out, and that's kind of what happens during a liqui-flow, except much more intense. Now, because of the unique geology of the Yellowstone Supervolcano, that superheated steam can travel really far. A 2021 study estimated that if Yellowstone erupted with a liqui-flow, the blast could reach all the way to Canada and parts of Alaska. Hot, heavy ash would cover areas the size of Connecticut and Rhode Island combined. Even worse, those ash clouds could block sunlight and cause global cooling for years. So yeah, you see why it's important to keep an eye on this behemoth. That's why scientists are constantly monitoring the swarm of earthquakes happening around Yellowstone. These quakes give us clues about what's happening under the surface. If the magma chamber is getting bigger or the pressure is changing, it'll probably trigger an earthquake. Scientists have been tracking this activity for decades, recording the location, timing, and strength of each quake. And in the past, they mostly saw smaller quakes clustered near the edges of the magma chamber. But recently, scientists started noticing something new, quakes that were happening deeper in the magma chamber and in a different pattern. That's why they decided to take a closer look at this one earthquake that happened in 1985. The quake was a magnitude 7.3, which made it one of the biggest earthquakes to hit the region since scientists started keeping records. But until recently, we didn't know much about the quake. We knew it had happened, and we knew its general location, but we didn't know the exact location or how deep it went. So, a team of scientists led by Jamie Farrell at the California Institute of Technology set out to find out. They collected data from various sources, including the United States Geological Survey and local residents who had felt the earthquake. Using this info, they were able to get a better sense of where the quake had hit. Then they headed out to Yellowstone to collect more information. In particular, they wanted to learn more about the area around the town of West Yellowstone, which had been badly damaged during the earthquake. They gathered data on the types of buildings that had been destroyed and how strong the shaking had been in different parts of town. With all this data in hand, they used a technique called inversion to work backward from the effects of the earthquake to what might have caused it. Inversion uses math to find the best fit model for your data. So, for example, if you know that an earthquake caused a certain amount of damage in a certain place, inversion can help you figure out the likely location and depth of the quake. After working through tons of numbers, the team came to some interesting conclusions. First off, the quake's epicenter, or the point on the Earth's surface directly above the focus, was much closer to West Yellowstone than scientists had thought before. And second, the quake's depth was only about 6 miles deep, which was much shallower than expected. Why does any of this matter? Well, the new findings suggest that the magma chamber at Yellowstone may be changing in ways that we weren't expecting. The fact that the quake was so shallow could mean that the magma chamber is getting bigger. As the chamber grows, the pressure inside the rock increases. Eventually, that pressure becomes greater than the strength of the rock itself, and it breaks. That's what causes an earthquake. Plus, the fact that the quakes are happening deeper in the magma chamber could also mean that the magma chamber is getting bigger. Remember, we got this information by studying just one earthquake. More data would obviously help scientists confirm their suspicions, but based on this one earthquake alone, they've already learned a lot. For one, they've realized that they need to reevaluate the potential impact of another super eruption. Because the magma chamber might be getting bigger, and because it seems to be changing shape, scientists now believe that the next eruption at Yellowstone could be even more destructive than they thought. That's because the magma chamber could be creating more pressure near the surface, so when it does blow, the magma could move more quickly and in more directions than they predicted before. Not exactly the news you want to hear on a Tuesday, but it's good that scientists are on the case. They're currently working on updating models of Yellowstone's eruptions to account for this new information. Once they have a better idea of what to expect, they can share that information with officials who make decisions about how to manage the park. That way, if an eruption does happen, everyone will be better prepared. It's also good news that scientists are using a variety of methods to monitor the volcano. Sure, earthquakes are a great indicator of what's happening below the surface, but there are other ways to check in on our old buddy Krusty. For example, scientists can measure changes in the shape of the land around the volcano using instruments called tilt meters. They can also use satellites to track changes in the amount of heat coming from the surface. And they can sample the gases coming from the vents to get a sense of what's happening below. By using a variety of methods, scientists can get a more complete picture of what's happening at Yellowstone, and that means they can better predict what might happen in the future. Thanks to Jamie Farrell and everyone at Caltech for helping us understand our shifting map. Thanks for watching this episode of SEI Show. If you want to learn more about how scientists study earthquakes, we've got a whole playlist of videos on our channel.